How do first-generation antipsychotics block dopamine? Imagine a busy city where signals are constantly being sent along roads. In the brain, dopamine acts like a messenger, carrying signals that influence mood, thoughts, and perceptions. First-generation antipsychotics, also called typical antipsychotics, work by interfering with these signals. They do this by targeting dopamine D2 receptors, which are like parking spots for dopamine. These drugs act as antagonists, meaning they sit in these spots without activating them. By occupying these receptors, they prevent dopamine from attaching and sending its usual signals. This blocking effect reduces the overactivity of dopamine in certain parts of the brain, which is believed to help lessen symptoms like hallucinations and delusions seen in schizophrenia. The brain has several pathways where dopamine acts, and first-generation antipsychotics affect all of them. In the mesolimbic pathway, too much dopamine is linked to positive symptoms like hallucinations. Blocking D2 receptors here helps control these symptoms effectively. In the mesocortical pathway, dopamine issues are associated with negative symptoms such as lack of motivation and cognitive problems. Sometimes, blocking dopamine in this pathway can make these symptoms worse. The nigrostriatal pathway controls movement, and blocking dopamine here can cause side effects like tremors, rigidity, or involuntary movements. Lastly, in the tuberoinfundibular pathway, dopamine normally inhibits the releases of prolactin, a hormone. When dopamine is blocked, prolactin levels can rise, leading to side effects like breast enlargement or milk production. The goal with first-generation antipsychotics is to block about 70% of D2 receptors. This level of blockade helps control psychotic symptoms but also increases the risk of side effects. Because of their strong dopamine blocking action, these drugs are effective for positive symptoms but can cause movement disorders and hormonal changes. Overall, they work by occupying dopamine D2 receptors without activating them, which reduces dopamine signaling in key brain pathways. This action helps manage schizophrenia symptoms but requires careful monitoring to balance benefits and side effects.